Hello, everybody. Good, good morning, my time, and good evening. Some of you joining from the other side of the world. Appreciate it. No. Hello. Mm. Hi. Hello. Welcome back to lesson two, multi-agents. And I hopes that if you are just here the first time, I'm also going to do a quick recap. So anyway, and my name is Tom. I'm a professor in computer science at the University of Colorado Boulder, and this is the course I'm offering with the support of GenAI.works on this four-lesson mini course on agents. And in lesson one, which happened last week, we had um, we talked about agent. So today we're going to talk about what happened with multiple of them, multi-agent. So let's just wait for a couple more minutes as I'm just reading through and you are telling me where you are from. So I'm seeing all of you from some from United States and good morning, some from Europe, good afternoon, and some from India and Pakistan. Good evening. Thank you for joining. Um, so let's just wait for just one more minute, a couple of minutes for people streaming in. All right. Oh, from Morocco, from Bangladesh. Hello. Um, all right. So I'll do a quick introduction. Today, I have my student Anna. I'm going to share my screen now. My student Anna, she's going to be a TA supporting me, and she will be monitoring the question and comment on the YouTube live, and she will respond to your question as much as she can. And I'm very proud of her. Just a few weeks ago, she and her team got the first place in this AI tech ethic competition at our law school in my university, and that's her here, and she's been teaching with me and making various videos. And for instance, this is the video she made about multi-layer perceptron and calculating it by hand. Anyway, so if you see Anna kind of posting to your comment, and you know that she's helping me, just helping me out. All right, let's see. People still joining. Okay. All right, so if you miss lesson one, so this is a very quick recap of what we did in lesson one about agent. And when I started to hear a lot of agent being talked about in the social media, in the news, I just feel very confusing, overwhelming. There's just so many things happening coming from different angles. So my experience is that you're trying to make sense of it is that you need to come up with like a framework you can consistently apply to help you understand and analyze what's going on. So lesson one, we kind of talk about this one framework to help you understand what's going on with agent. So this framework consists of four elements that are added to large language model. These four capabilities of an agent are thinking, seeing, remembering, and doing. Can think, see, remember, can, or in past tense, thought, saw, remembered, could. All right. So I give you an optional assignment. Just so happened last week, OpenAI released their own agent API as the perfect timing cannot be more perfect for intent for purposes this class. So I decided to just quickly put together this assignment for you to apply this optional assignment for you to apply this framework. So we hope we can review this real quick. I hope this resolution is good enough for you to see what's in the text. It's not clear to me from my side. I believe we are streaming at 1080, so hopefully it's fine for you to read some of the text. So start with thinking. where can we see? So this is the screenshot I captured from the OpenAI's website, and to try to simulate what the experience is going to be like. Even anything that anytime there's something new that comes out, that's what you can do. You just if it's about agent, because where can we see that kind of evidence and behavior of thinking? So we talked about, well, when you add this instruction, is that it held explicitly asks the agent to think you should be friendly. I can read this for you. You are extremely friendly and helpful. So this is how that the age that there's a key capability of the agent beyond large language model, that it will know that I have to be friendly and helpful, and it will trigger a whole bunch of the reflection process that trying to be friendly and helpful. Okay, and then turns out in this part of the code, it's trying to create another agent. You say, okay, you should be a bit more formal. You say, how do you do? How have you been today, sir? So this kind of format. That's what started to talk about that. And seeing is the observation and being able to perceive what's going on around you around large language model, mostly from users, also from the environment. So the evidence I'm seeing here is that oh, you said greeting here. So this is a greeting coming from the users. Whenever there's a user input, for instance, here input hi agent. So this is trying to simulate how the user could have talked to the agent. So coming from user. So agent. So in fact, when we just talk about large language model, if we focus on just a model, it's just a way to predict the next word given a sentence. So it's what that model does. But Chat GPT is adding the chat capability. You can think of it. Chat GPT is already kind of toward that direction of agent, even though it wasn't formally called agent earlier, but it has this large language model with the perception, seeing what user is seeing. And remembering is that after seeing after hearing from the user, okay, where can we see remember? So usually is part of this context. They put in the context. And then here also here this code saying that, well, we're gonna store user ID. Also seen some messages with this array. So this introduction course. So my intention is not for you to become familiar with coding also, nor, but I want to just give you an idea that you should not be too afraid of what's going on under the black box. When today we're going to open up the black box about multi-agent as well, you'll know that is some sort of code, and even though you don't understand, you don't need to be able to write the code, but you can actually see it. And if you take a moment to look at the code, you realize, hey, it's not that hard. I can actually understand why the agent or multi-agent system being coded in a certain way. So that's what we'll do today. And about ability, here is the tools, and being able to greet users one ability. So that's what I will highlight, but I've been seeing a lot of submission from you, and it's fantastic work. Okay, so please stream full. Okay, I'm seeing some comment. Apparently, we are not streaming full 1080p. I'm not sure why that is the case. Same, if you are here, do you know why it's not high? Is it because on the YouTube side or on our
Yeah,
side?
it's on the StreamYard side, everybody. So what we're looking at is in the settings, it doesn't let us switch over to 1080p on your YouTube today. So we'll definitely record this session, and then for those who do have any issues, just let us know. But the key thing is on the next session when we go live, we'll be able to adjust the settings there. But I think on your YouTube, we can't push to beyond 720 right now.
Okay. Anyway, so knowing that I'm going to read, if I have a small font, I'm going to read it. Don't worry. Most of the things I have on my slide quite large. You should be able to make out, understand, and follow. Okay. So that is what we cover in lesson one. We have give a framework to understand an agent. You can just pay attention to what the agent must be thinking, must be seeing, how it's remembering, and what it can do. And so today we're going to talk about multi-agents. But for some of you, you might be listening, joining my lecture for the first time. You might be wondering, what is AI by hand? So this is kind of my response to this feeling a lot of us, even including myself, feel that AI is advancing so quick. It seems like a black box. It's kind of hard to understand what's underneath AI. So I've been trying really hard to work with my student. Maybe there's a way to open the black box and use your hand to open the black box and write on the paper, and then using your pen, your hand, and paper that is to get this feeling that hey, it's what's under this black box of AI is not that hard. For instance, this is neural network computation that I collected this example from people over the world. So this is what I did in my class, and students submitting, also other people in the community submitting their sketches and drawing, and for transformer, for neural network, even kids could color it all by hand. And then this is an example of the deep sea lectures I did a few weeks ago, and I like to encourage people to follow my drawing. So I want to encourage you to do so as well if you have not done that with me already. And I had this math workbook, and it's helping a lot of people unlock and understand what's under the black box of math under neuroscience. I mean, that's neural network and deep learning. And I decided to make this certificate. If somebody finish it, I make the certificate and sign, and to just whatever it takes. I think that I like to uh, convey this idea that we should not be too afraid of understanding, getting into the black box of this neural network and deep learning and AI. Today, we're going to talk about multi-agent. And so we did that for a lesson one. I encourage to people to submit, and we have received, I'm very, very happy we received like hundreds of submission. And I just pick some 8 to show you today. And then Samuel, Vincent, Shita, Georges, and Kedar, Tiago, Mayor, Maria, and many, many of you. I would like to I hope that I could get to know you more as you follow my course. And so that's what we went over in lesson one. We have this agent template, and for you to write how the agent should think, how the agent should remember, and how the agent should act, and how it's connected with large language model, the green part, and also for your own data. Okay, and so that, and if you see 8 of them, is multi-agent, and you have to ask this question. Okay, so how, if we want this agent to talk to each other, how do we facilitate that? How do the agents take turn? How do they all coordinate? How do we manage the coordination, and so on, so forth? Okay, so that's what we're gonna go from here. And I thought, well, I'm inspired by seeing your beautiful drawing. I decided for this, I'm kind of prototyping what the certificate should look like. That's what I kind of have right now. I might have to. So I based on Maria Petrenko, if you're here, and I thank you for posting about this. And so I use your work as an example that I thought maybe if you collected 4 drawings, and then I will just sign this and send it to you. And I've been learning how to send stuff. For instance, so I've got this envelope, and I learned that in the US, if I want to send, I just need 2 stamps like this. Let's see. That's what I'm gonna do. I think it's kind of fun. I'm gonna do just simulate what's gonna happen. If you finish this, I'm gonna sign the certificate. I put these 2 beautiful stamps, and with another one, I think I need another 5 cents to add to it. So anywhere in the US, I'll be able to ship this certificate to you. I'm still going to learn how to ship it to internationally, but well, I think if you work hard and submit, I am motivated enough as well, trying to do the research, then getting to know about how the postal system work across the world. It's new to me too. Anyway, okay, so that is answer the question a lot of you. What kind of certificate you can get? So this is the prototype. Hopefully, we'll continue to refine. It's an experiment for us as well. How we'll share this certificate in a way that is kind of unique, that you get something I signed by hand. All right. So today, finally, we're starting multi-agent. I hope that you're still with me. So, well, we kind of revisit this template we have. So to code that, what I would like to see, we can actually design agent by hand. You don't have to jump straight to your Jupyter notebook or coding or some interface. Sometimes you can just on a piece of paper. I've seen lots of people sharing their agent diagram on a napkin and all that. It's pretty cool. So this is some PowerPoint slide, and this is a template I like to use. I already been using it for my class. So say I'm going to design an agent, but first of all, because I actually do have I have my own data. I may be running a business. I have something that I have to build upon. So I have a customer data space. I just start with what kind of data I have. I have lots of customer database here, my customer relationship management system, and also I have some orders that database. So these are the data I have. So I like to develop agent to could interact with as a interact between the customer, which is this person, and also the database about customers and also orders. So that's how where you start. Also, I like to make sure I'm using a really strong model, this large language model that different vendor can choose from. So let's build agent to fill it in and multi-agent. How does multi-agent work? So to build agent, first you have to think about what you like agent to think like. So we talked about we could just use this here to write down my role for the agent. I want you to be helpful. Say this is the I want to build some agent that can work together to handle like refund, handle like customer satisfaction sort of process. I want to first have a helpful receptionist that can answer the incoming phone call. So I just say helpful receptionist. So with that, even just with 2 words, in reality, maybe you write a lot more word, but even with this 2 words, if you add this to give it to large language model, you will know that in order to be helpful, in order to act like a receptionist, there's the kind of logic that should be operated behind the scene. Another agent would be maybe I want to have a manager, but a manager, I like it manager to handle the relationship. So I would say maybe like generous manager, generous manager. So talk about how, so to think, take care of the thinking part. Okay, and then I will now I can think about actions. Now I have 2 agents. One of the action could be that well I could transfer to manager. So I want like to one of the tool to be actually not really doing stuff, but more like transferring to a manager. Another is that maybe I can look up my database who to understand who that person is. And when you design a general manager, it goes through the same thought process. Like, oh, what is this agent thinking? Like a generous manager, what can this agent think? I do next is that maybe manager could issue refund. Also, it could also reply to the customer or reply to the receptionist. So that 2 action that you could write in. Okay. Now this is all we have to do to code design multi-agent system. That's all we have to do, and focus on what your agent need to be and also what agent can do. And next is that we want to map out how exactly these two they can interact. I just want to draw a scenario how this can run in action, handling a user request. So now I've coded by hand this multi-agent system. What's going to happen is we start with the user saying, for instance, user gonna call in. So these are the blue part is what the user is thinking. I mean, sorry, seeing what the user is the agent is seeing. So this is the C part. Okay, seeing the user is calling in. So what can the agent observe? You're gonna say, well, we most likely get a phone number. Okay, and then that's it. And if we take this definition, the whole helpful receptionist, you see the phone number, you have 2 options, manager, transfer, or who. You send this to large language model now. So large model will just process this and make decision for you. Hey, maybe the tool I want to trigger, the action I want to trigger is actually to look at who is actually calling or what is actually helpful receptionist. It wouldn't be thinking like who the hell. It would be thinking about who for whom can I have a pleasure to serve? That's most likely the kind of thinking that they will engage. So they will come who, and the who we're going to trigger a database looked up. So now, okay, now I want to look up my database. It's probably my traditional SQL database, or it could be a vector database, and realize, hey, based on this phone number, well, this person is a VIP, and his name is Tom. Okay, so that looked it up on the customer database. These are information not provided directly from the user right now. It was looked up, and the large language model provides the kind of logic to tell the agent that, hey, next thing to do is to look it up here. Now you look at this, what's in the gray box is that the entire this agent definition with knowledge, with memory, with action, it's got expanded with VIP, Tom, and phone number. Now this whole thing gonna pass to large language model again. And last lesson we kind of review that each one of the things I wrote down here imply a prompt token you have to feed to large language model. You might have to even pay for. So this thing can be expensive if you actually you can see very. And so now with this, so well, I see. So maybe the so the with if with a phone number, you actually also hearing the Tom is saying that, hey, I want to demand some refund. Can I get refund? And so when this together, good large language model is okay. Now I have enough information. Maybe I should transfer to manager. Is the more reasonable next action. When that happen, that's when this transfer gonna happen. So now this control transfer to the next agent, who is a generous manager. But this generous manager, it doesn't initially doesn't know anything. Is probably will be, oh, what's going on, what can I do? So we also have to work on transferring this memory. So this is, I forgot to write it down, so it's more like memory where you can contact transfer this to the agent. So this thing got transferred over here, and this information also transfer over here. So I can just write phone number, and also the customer's request demand refund. So it's a copy over here. Demand, actually fix this, demand refund. Okay, so copy over here, and then again, all this is being fed to a large language model again. So given that this is generous manager, given this memory or context VIP at Tom, given that we have seen phone number and the user saying that demand refund, maybe the reasonable to do is that I want to issue a refund action. And this refund action probably will have to go to my orders database to look up the order that's placed by Tom at VIP a while ago. And then look it up, hey, that transaction is actually worth $120. Okay. And then this, with all this kind of sent to large language model again, and large model has all the information I need. Okay, given everything I know, I could finally issue a reply back to the customer that this reply, what would the reply be? The reply is going to be, okay, yes, sure, I'm going to put $120 back to your credit card. So this is like whole the kind of loop involving two agents, involving four interaction with the large language model. Then each green arrow will encapsulate all the things in this box. That with your role, with memory, with seeing, with tools, actual actions, and so these are can be expensive with lots of token, and then what the large language model return can be expensive too. So anyway, but it does simulate how in in the in the in our human world, that is how a helpful receptionist agent might kind of work together. Okay, so it's kind of a quick overview of what I put two agent, how you could work this out, all the logic, simulate the logic just by sketching. Hopefully you are able to follow it. So next I'm going to go to show you some practical toolkit with. So first we're going to look at OpenAI Swarm toolkit. That was released about a few months ago, and last week they released a mature version of this. But I think it's still useful to go back to the Swarm because it's simpler, and that was designed as more like educational agent API for people to understand what's going on with multi-agent. And Swarm is like lots of bees. Okay, and then later we're going to also talk about Crew AI and to look at their multi-agent capability as well. Again, you're trying to focus on more like generalizable theoretical framework, and this framework for you to be able to apply to your own study and research on multi-agent in the future. So let's look at this code again. Well, again, my focus is not for you to learn how to code this, but I just want to convey a sense that it's not that magical when you open the black box. I just encourage you to kind of open the hood. That then if you understand the framework template to the right over here, you could count on if somewhere in the code must be related to context, must relate to this box or this box. So see whether we can dissect this code and trying to build what this code must be doing in terms of building an agent. So what we're going to do now is to use these are actually two agents, A and B. Let me use my plugin. So you can see here says agent A. Here says code for agent B. So now, okay, well, I do have two agents, agent A, agent B. And now the first is like, what should agent think? Here, that's where you can find. Okay, instruction right here. You are a helpful agent. This is very generic. So helpful agent, helpful agent. Okay, all right. And what about the next agent? Okay, your name is agent B and only speak in haikus. So speak, you are able to speak haikus. So, well, this is based on the real code on the OpenAI website related to Swarm, the repository. But that's how I will summarize this what these two agents do. And then next is that about this part action, two actions, but you could imagine have more actions. So what are different actions? Let's use a different color. Maybe use this one. So, okay, this function seems to suggest, well, maybe that's where I would be defining the actions of agents. And so in other toolkit, maybe they call tools. It could be like actions, but here it's called function. But you know they refer to the same thing, these two boxes. So the first action is transfer to agent B. So I'm going to denote like this, transfer to agent B. There's no more action or function here. And for the second agent, if you look at the code, you realize it doesn't have anything. Just this is it. This is it. So this is a simplified version of representation of what these two agents should work together. Okay, defining two agents. Let's look at another example uh, also from the Swarm API, the web page. So in this case, I don't longer have to write, but I can just quickly see the correspondence. I'm going to use my red, maybe purple again. Purple, maybe use green to denote that this raw part, user interface agent, the thinking part, user interface agent, and your user interface agent. So this is okay, telling the agent how it should be. And then for tool is that use this color. So transfer to help center here is this tool. This a lot faster here. In this case, another agent is help center agent. Help center agent. You are the OpenAI help center agent, so it goes here. OpenAI help center, and this highlights some function or action. So you have query docs, be able to submit ticket, be able to send email. So you would like to just represent this visually using this diagram. The corresponds to query documents, being able to send email, being able to submit tickets, and this just to emphasize that this thing, what I'm representing here, is how the prompt, the overall prompt would look like. Overall prompt will have all this, and these are being sent to a large language model to generate responses. Then you can they will all represent lots of tokens here. You can even count the number of words. That's how you have to pay for agent interaction. Okay, so this is a quick give you a quick example of how you can apply this to analyze what the agent really is, and just by focusing on what the agent is thinking, what the agent trying to be, what the agent can do, and so on. And then this is the same framework applied to Kuro AI as well, or actually any framework. So you can still use this one to think about. First, I want to think to identify well, where this part, right? So this is a researcher agent. So that the role is a senior data researcher. Goal is uncover cutting edge development in some topic. Okay, so this is and there's a backstory, and it turns out there's a lot of things instead of just couple words. This all kind of go to here to define that. Well, this is a researcher agent. So all this word will end up filling in this part, and let's just look at the next agent. what is the next agent? Is a reporting analyst. So this is a report analyst agent, and then have a very extended talk about this reporting analyst has a goal and has a backstory. So these are all being fed into this part. So this is also based on real source code. When you're design an agent, that's what you will write as well for your own task. So more you understand the particular vertical, your domain application, the better you are to write this sort of prompt to position, to prompt the agent to just think properly, just like what is expected to do for a particular task. And let's look at the next one. Let's focus on some other part of the code. So another part of the code, you'll find that somewhere in their code base, you'll define a bunch of things the agent can do. In this case, use this color. So it turns out it is in this task.yml file. When you open it up, it's not like scary code, but it's actually just plain English. What does it say? It says for a research task, that's what the research can do. What can you do? You can conduct a thorough research, make sure to find the interesting, relevant information given the current year. Expect the outputs like this with 10 bullet points of the most relevant information. So this go into the definition of one of the capability, and this capability is called research. Okay, so you can, looking back to the swarm example we just looked at, and the tool is actually quite simple, just one word saying that I'll greet the user or transfer to another agent. But here, it's in a more sophisticated tool, agent toolkit. You can write a lot more to define what the tool is. But again, you can see a lot more plain English than actual code. So that's where there's a lot of opportunity for people who understand your vertical and domain to contribute to agent design. When you hear about that, it's because of exactly this. When you opened up the source code, you open up the black box, you realize lots of plain English under the hood. So here, let's look at the reporting task. Similarly, you can review, you can report, make sure to report, expect the output that's here, and they all kind of go into one of those boxes for your agent capability. Let me just call it report, one of the actions. Okay, so kind of back, so you can see this is the think, this is can or action, and they're all in plain English. Next, let's talk about the process. Going back to this really evolved diagram I went through. So what I want to focus on in terms of process is that just pay attention to this process. How does a manager agent transfer control to the next agent? So this is some certain process that define how multiple agents should work together. And so there are different multiple patterns that's been people have tried and also this framework for multi-agent framework tend to support. So look at some of them. So Swarm, going back to Swarm is more for education purposes. So it has a very simple process. It's called sequential process, and it goes from I can just show you what it's like. It's like also like a list or like a loop, but it goes one agent to the other agent. It tend to have this pattern that you have just a lot of transfer of control here. So for instance, first step, maybe we start with agent A. Agent A, with the context input from the user and to large language model, might say, okay, maybe next reasonable thing to do is pass to the agent B. So maybe this get selected, and you'll go pass the control to agent B. So second step, B will take the prompt context input and will realize, hey, not the agent B decide that it should control. It's more about given all this fit to the large language model, very, very powerful model. They will determine, hey, C is transferring to agent C is the most reasonable next step action to get transferred to C. So it's my step 3. And C with the prompt context input and possible action to data information looked up action here, and also transfer, and decided, well, I would like to transfer to D, so it's get transferred to D, and step 4, and repeat. Maybe D say I want to transfer to A, and now have this loop. So it could be, so you can see that this list and loop is a sequential way to transfer control from one agent to the other agent. And next is hierarchical process that Crew AI also support this, and then we're gonna see what does it mean by supporting this. So we'll have this hierarchy. Right? It's like that we'll have a manager at the top, and like in my family, my wife is the manager. So so it's three different agents. So if I design the manager option, a manager agent over here, maybe all the action is basically delegation, delegate to A or delegate to B or delegate to C, and that's how I so the manager might be defined, and this just simulate how they could operate. So to execute this framework, maybe the first time, given the context input, manager decide, well, we should transfer to A, so we're gonna pass to A, and A is and then after A is done, then they will transfer the control back. And second step, maybe they'll say, okay, I'll transfer to C, and then come back here, and then after it's done, maybe B now, and come back here. So there's a managers always passing the control and receiving feedback in a hierarchical manner. Okay, so that's what this hierarchy. And so let's see how when you hear the frame, you hear that we have a framework supporting a hierarchical process for agent to coordinate together, and then you will say, oh well, and I like things like Crew AI, this open source software. You can actually read the source code and understand a lot of stuff. Open a black box engine hood and understand what's underneath. It turns out is a lot of English here. So if you how do we really define a manager action? It turns out just take all this green, write a lot of English, and just put it right here. What does it say? You are the crew manager, and your goal is to manage the team to complete the task in the best way possible. And you have a backstory. You are the season manager with a knack for getting the best out of your team. You are also known for your ability to delegate work. Okay, you delegate work. This seems to imply you could delegate. This is one of the actions, delegate to the right people and ask the right question to get the best out of. So so just like a lot of this English, you can put it here as part of the prompt. All right, so this is manager implementation. This is a real world implementation in Crew AI at the time. And over time, every time they update, of course, they realize they have to update this prompt as well. So if you go to the open source repository, that might look slightly different, but the essence is the same, plain English. Somebody worked really hard trying to get it right. All right, and then there's some code too to facilitate that what's actually kind of wrap around. Um, so if you could not to be too afraid by this code, we could just break it down again. So here we defining the agent, and then there's some kind of code that retrieve some of the things, retrieve role and go and backstory. That's what we just looked at earlier. So these are role, go, and backstory, and this is the actual code to put it. When you run this actual code, what is going to take role, go, and backstory, and just like populate your template with those English text. But if you have I think they are preparing to make the agent more universal, can understand other languages as well. So that's why I use I18N here. And you can imagine somebody can write this in Chinese or in some other languages that could bring to building some particular work style for that particular culture. That's also possible in the future. But then, okay, and then here we can look at the tool side. So you have this code that agent tools, and you load these tools into your agent template as well. And this just go into populate this in this toolkit. That's how the code to do. So we'll say, well, I can delegate to A, delegate to B, and delegate to C. These are three different ways you can delegate. So that's how this code does. And and that's now I just want to just show another pattern. So it is the manager pattern that we just saw before hierarchical, and to go a step above in terms of complexity, it will be go from tree to graph. And it turns out that is simply just let if you add more like this sort of hard not being able to for A to control pass control to B and B pass control to C can go horizontally as well, and this is how you have a graph. But essentially, is an extension from the hierarchical. And in terms of implementation, basically, if you see that agent, one of the tool is to pass another agent, not necessarily back to the manager, but back to kind of horizontally in any direction is a graph. Okay, so you see this pattern as well. Right now, we focus on a lot about process, about moving control, coordinating the process, coordinating across multiple agents. So next section, I'm going to focus on this horizontal arrows we drew earlier about communicating. How do we communicate, facilitate agent communicate? You can pass knowledge and information over, so that you could provide some consistent experience with the user you're trying to help or the problem you're trying to solve. Okay, so this part is about communication. So going back to Swarm being again an educational tool, agent tool, and it has this very basic communication mechanism, basically handoff approach. So this is the sequential transfer process we looked at earlier. So in a hands-off approach, basically what it does is that it's just going to pass information kind of over and over and over again. So I'm going to simulate that process by adding a bit more to so simulate how communication happens. So this, what I have here is the simplified diagram of this, just focus on process, but I'm going to add communication now. Okay, hopefully you can bear with me. So with communication is that something that this context is going to just, when A passes to B, the context is copied over, hand off the context. But suppose B, before passing control over the C, B actually realized, hey, I want to look up some information to my database. B has some kind of database, look it up. Information added to the context. Say, look it up, hey, I have this plus. Okay, and this, when the plus is, when it's passing out, so this plus actually passed to C altogether. So hand everything off to C. And when what C does, maybe in C, let's use different color. C decided that, hey, I need to look up something as well in my own database, a separate database, and looked up something. Maybe it looked up a triangle over here. And then when C is about to pass to D, all the information, the triangle, and then this got passed as well. So they will be just copy over here. And then when D decided I need to pass my control back to A, and then A will kind of fit into input over here, or fit in the context depending on how actually this fit it back to the context here. Now A finally have everything it needs like this, but it was provided by other agents. Each of it has its own way to look up data and so on. Okay, so it's hands-on approach. Actually, you can see that in this very basic way, amount of information had to pass and also have to include in the context to feed to a large language model just increase over time as it becomes more complex. And then so that's why in a more advanced framework, they'll use things like for instance, question answering is a way to facilitate communication. It is one of the things supported by Crew AI, and you can also think of it as more like function code. So in this function code, okay, and then so when A trying to say, hey, instead of passing into C, it's going to just say, hey, I want to ask you a question. And when C responded, and C maybe will look up some information, one of this action looked up information and pass to the context, and next then is to pass back to A. So it is the question function code. it's not passing things around, but just asking a specific question and getting a specific answer. Add the answer to your context selectively, so you have control over how you act. So it's slightly more complicated, but it's not that hard for you to imagine what the question goes. Kind of like you call somebody, you ask the person, but then in the previous case, imagine a notebook. Every time you are done, you pass the entire notebook to the next person. The next person can add more stuff to the notebook. So two different kind of interaction. Another way is like message. So each agent will just add stuff to this message, and then or you can listen to. So for instance, I add a triangle, and next agent could say, "Hey, I just want to wait for the listen to a triangle every time." Actually, this will be more implement here, the input part, what the seeing. I just keep seeing this. Do every time I see the input message queue have triangle, for instance, maybe like process order, a check for a transaction, and so on. So then it will trigger some interaction. So everybody just puts stuff into the same place. Almost like you have, imagine you have a bulletin board, you just put the notes there, and everybody can walk by and decide whether you want to take something down from or act upon what you see on the board. Okay, all right. So I talked about handoff, QA, and messages. There's also other more ways for agent to communicate, but I I hope that a takeaway is that these all correspond to all humans like us. We already talk to each other like this way. That there are some business process that each of it trying to simulate. So if you ever have to implement agent, multi-agent framework, so you're trying to match what you are already doing with your colleague, that could actually be more successful instead of just picking a random mechanism. So next section, I'm going to talk about the memory, to break it down into short-term memory and long-term memory, and how that operate in the agent framework. So in this case, similar to the problem we looked at, the example we looked at, processing refund and get $50 back. Okay, so we have two ways to store memory. So this is just one transaction. Okay, can you process the refund? And the receptionist passed to the manager, and the manager decided to return $15. So we looked at this transaction. And then usually you will say that what else can I help you? And maybe this user does have something else that the user want to work on. But it's important for the manager and receptionist to know, to remember what he did last time, so you wouldn't be asking the same question again, right? So this usually being preserved, that information like this transaction history. So we have response, interaction. This will go into the short-term memory here. Usually we'll use a vector database because it's quite close to this embedding being passed around the large language model. So, and you can look that up. And the purpose is that the next time when the user interact, when next time when have a what happened is that, and this is little transaction that being stored here could be added just into the context. So the receptionist remember that, hey, I just helped this person process the refund. Now if the user say again, hey, can I process a refund, you say, oh, didn't you just ask us to process a refund? So have some continuity in the interaction. So that's usually maintained here. Okay, so how about long-term memory? How can long-term memory help? The long-term memory is that you take a step back to reflect upon the whole process. Maybe you reflect upon this entire process refund, $15 back, and you can say, hey, let's evaluate how well I actually did, how well my agents are actually doing. And you send this thing to a really, really smart, powerful large language model. They say, what can I improve? How can I improve this process? And this large language model say, hey, based on my review of this interaction, I gonna give a quality score. This quality score say 7 is good enough, but it can improve. For instance, one way I suggest you can improve is that, well, you can be more polite. So this some kind of feedback even the model can give. And this feedback, it goes into the long-term memory, for instance, SQL. And that would be kind of like change the personality or the way that the character of this agent, they usually go to long-term memory. As it's like it matches how human learn as well. When we learn an important lesson, we want that you to learn. I hope that as you are following my lecture, you realize getting things down by on paper is a good way to learn. I hope that go into your long-term memory. So this because it's more about how you can improve as a person. So that go to long-term memory. And next time they could be put into a context as well and to become better for the next customer. Not necessarily for the same customer, maybe it will be useful for the next customer. Okay. Hopefully this illustration allow to help you understand the difference between the two. And then you can actually see that in the code as well, how it's being implemented in Crew AI when you open out a black box. So it's actually being done. In this case, I'm gonna focus on this. Where can we see code that responsible for short-term memory? You can see here, short-term memory, create short-term memory, and basically save what? Save output, which is here, the $15 back, and observation, observe the process refund. So just what's happening with my current user, short-term memory, goes to, where does it go? It goes to just put it in the context, keeping passing around or big database. And then there's a long-term memory implementation. So long-term memory is, I could choose green. So long-term memory item, what is it? It's going to take the test description, also the output, and also the output. I'm going to do some evaluation, and then it will save the suggestion quality. Just call why I talk about this part. Okay, improvement, becoming a beta agent goes to the long-term memory. You can see that it reflected in the code as well. And all right, so this I talk about framework, about aspect, about memory, about communication, about process, and also about agent. So now I'm going to apply them to help you get a sense of, well, every time you come across a new multi-agent framework, or we're trying to build one, or trying to design one for your company, what will be the kind of thought process you can work to apply this framework to help you? So I'm gonna take OpenHint is one of the most popular multi-agent open source software. If it's successful in the software engineering, the domain, helping people code and debugging and so on. So these are the screenshot this of their system, and they would check your code and trying to fix bugs and submitting issues and so on, and very powerful. It's a multi-agent system. And you look at this open source, so they will tell you the system architecture diagram. So this is an example of the diagram I pull out from their website. Isn't it pretty intimidating, right? If on someone who never have to deal with this before, okay? So it seems intimidating. But if you have the right framework you can apply, you can break it down in a systematic manner. So what I'm going to show you, the first you want to understand is that if it's multi-agent framework, somewhere there must be defining a bunch of agents. So where are they? So here, this agent, if you realize this diagram talk about agents, and then okay, what kind of agent does it have? It's a coder agent. You have some mass agent because it says right here, and you also have some fixing some type fixer agent. So okay, this is my agents. So then next question is that what is the process to coordinate this agent? It must be somewhere in this diagram. When you look hard, you realize there's a controller here, and there's some managed state. So this imply that process, this must be sort of has a manager. So the process probably has a manager, which you have manager, and tend to imply that you have the uses hierarchical structure. We have a manager agent to decide how to delegate tasks to different parts of agent. So there's a hierarchical process. And then next is you ask the question, so then how do you talk to each other? So you're trying to look at the way to communicate. Where can you find communication? So I find this event stream. So, well, event stream seems to suggest that it is using messages, using kind of message queue. So one of the pattern we look at. It's not just hand off. Also, it's not based on question answering. It's a message queue. Makes sense for this very complex text. And then next is we also look at the memory. Memory, let's use switch color. Use maybe this color, I haven't used it yet. The memory, where do we handle memory? And so here, okay, some storage. Maybe this how the memory is stored. Instead, it's going to use S3. It's an online cloud storage and local and memory. And then it could imply maybe that for memory, storing memory something fast, it must be for short-term memory. This must be a long-term memory, long-term memory. And for S3, probably some archive you can use. Okay, so that's how we'll break down using the same. And then let's lastly, because you also have you need the large language model. So you can see a large models here. You have two model, commercial model, you can use open source model. Okay, makes sense. So there's a one framework, we'll break it down. Okay, and that kind of in the use just do it one more time for this academic paper. You can also see very quickly that you have agents here, all the agents over here. You have some kind of process, and look to me like a graph. So you know, it's a graph, is a process, actually, graph, and you also have communication. As how do they communicate? You realize they are passing writing report, also some kind of a function code here. So this suggests a way they are also passing messages between each other, but they doesn't use a central message queue, for instance. And next is memory. Memory. So it turns out, oh, it's not clear. It doesn't really tell you what kind of how they actually maintain memory. So if you work with a multi-agent vendor, there's a question I ask, hey, how do you guys manage memory? Do you manage short-term memory? Do you allow your agent to learn and evolve over time? How do you maintain a long-term memory? And large language model always imply they must be behind some sort of a really strong OpenAI model or cloud or so on, or open source model. Then you put process communication memory. That's how you can get a multi-agent system. So this is another way with graphical database, but we don't have time to go through. But similar idea. All right, to be able, you should be always can identify. Well, these are all the agents. And then there's a way the process of kind of passing them through looks like hierarchical. How do they pass? They pass graph, the nodes in between each other. Okay, all right. So assignment for today. Assignment for today. Let me see which one should I pick for you to replicate. I probably would pick the uh, slide number 16. Okay, there will be your assignment to draw that. And if you collected 4 drawing with 2 more lectures. Next lecture, we're gonna look at 50 best practices of AI agent, and then with the grand finale to talk about the futures of AI agents. All right, so I'm only 2 minutes left, but for before it hits 10. So same, I'll transfer. I'll do a handoff to you. Transfer my control to the same agent to wrap this up.
There we go. Can everyone see me? We hear me? We here. We made it. All right. Well, thanks everybody for joining. Tom, what a job. I think this was really epic. So many people shared how much they enjoyed the content. If y'all really enjoyed what you saw, let us know in the chat. We posted the links and everything in the resources tab, so you can get to that. And then as far as details, maybe some of the things going on, I'm going to cover some things to close out, what you can expect for the remaining of the course here. And so we have some people in the question asking, Tom, just to share, slide 16 is the OpenAI swarm. Is that correct?
Oh, no, sorry. This is a slide 16. Or maybe 17. Oh, the one before swarm.
The one before swarm.
Yeah. I think we'll have a one-off error.
Awesome. We'll make sure to update it in resources.
I have an extra intro slide. But I also share the blank version. That should be version. That's 15, right? 15 or 16. 15 in the version I shared out.
There we go. If anybody has issues, definitely check in. Anna as well. She'll be sharing, but it'll all be over in Mighty Network. So as we close out here, everybody, just remember, we're 6,000 strong. I know everybody can't make this time frame. We're all over the world, but definitely check out the recording. But chime in Mighty Network. So even if you weren't able to attend this live, go to the announcements tab, go to the Ask the Instructors, repost your questions there. I see so many amazing questions that are lost to the ether of the YouTube chat box. So I definitely recommend, if you had a great question or had a great point or something, post it in Mighty Networks. We can come back to it, and we can definitely follow up to some of that content as well.
And I hope I will be able to sign you a certificate so you could. We don't have a deadline other than by the end of this course. So if you didn't get to submit last week, that's fine. Just go back and do it. And also, if you just want to just enjoy my speaking without joining, that's fine too. There's many different ways for to learn, which that's all allowed and encouraged.
Totally. Spot on to that. And so one thing I just want to do is I want to thank everybody here. For those that were able to get in, we will most likely use this method. I did hear some feedback from folks about how they probably wasn't, YouTube wasn't the best for them here and there. But again, we'll work through that. If we have to go back to Mighty Networks, we will. But all in all, seems like we didn't have as many technical issues this time, which is exciting. And then as far as overall goals and opportunities, this group has done some special things. So I do want to just double tap on what I'm able to see and some of the things I recommend. Let's continue to grow this together. I mean, we truly have made a testament with the way that we work together and how we worked last week. And I've seen so many embers of that again this week. When people had questions about where the slides are, people were posting the link, people were resharing. When people had questions about how to, get visibility, people were giving tips. So across the board, what makes us so special in this community and what I'm so proud of each of you for is we really show up and show out. And so I just want to put a little bit of a stamp on that and really give us some things that we take away together as a group. So, hey, we as a group, there's roles that we're playing. I just want to make sure everyone could be aware of the things that I saw. If we continue to do this, there's no problem we can't solve. We could be the most powerful community in the world where we're learning these technologies, applying them, and helping each other grow. And so number one is being a helper. For those that are out there that were in the chat, always responding, taking time to answer questions, round of applause for you. The helpers are so important. You are the agents, and I shout out to my agents. And this role, again, is so critical. So you might not always play this role, but if you have an answer and you can help, definitely jump in. The next one here is having a researcher. I saw this so much too, where people would ask really good questions and we wouldn't be able to get back to it enough time, and someone would go do the research and drop the answer in there. So definitely playing those roles. This is very valuable, and it helps us as a collective organism, as a community, grow and learn faster. So if you don't have the answer, hey, but you know how to find it, don't mind finding it and post it back into the team Slack, the team Mighty Networks, or even answer the question yourself. Next one here, one of my most interesting groups is my Clippers. The Clippers are really showed out last week when we had issues with the screen size. Those are the folks that were taking screenshots of how to maximize the screen in Mighty Networks so that you didn't see both of our screens, you only saw Tom's. So for all those that are taking pictures or screenshots or even taking the video and clipping it up, repost it back in the Mighty Networks. If you saw some good things on the YouTube link and you wanted to bring those to the community and talk about them, cut it up. Use some of the different tools out there. There's a ton of them. Vizard. There's just a ton of tools out there to let you make instant shorts. I recommend we continue to lean into that as a community. You'll see me bring these up on every other call. But even if you can't do any of these three, be a resharer. So if you see some helpful insights and someone asks that question later, share that again as a follow-up. And so whether we're agent helpers, agent researchers, agent clippers, or resharers, let's make this community the amazing one that we know it is. I appreciate everybody for joining us today. Again, we have our next course kicking off next week. So again, even though this course will continue on, we'll continue to have 2 more lessons here. We'll have another course kicking off. And so there are going to be plenty of options and opportunities. This one is an executive education course. It's 10 weeks long, 8 instructors. And similar to this, it's very interactive. There'll be more breakout groups, things like that you could do there. And the opportunity with this that's really unique is when you complete it, what we essentially are giving you the opportunity to do is publish the work that you learn. So just like with Tom's, you're submitting your drawings. Here you would be submitting ultimately your capstone or your research project, and that's going to be published to our audience of 6 million followers. So a phenomenal opportunity. This is a paid course offering, but a phenomenal opportunity nonetheless. And you can check that out by either using a QR code or pressing executive education on the Gen AI Works website.
Same for those who are seeing us on YouTube but didn't know how to join Mighty Network. Do you have a link you can share?
Definitely. I'll share a link. The main key thing is come to our website, community.genai.works. That's our website. And from there, you'll be able to go right, scroll down, and you'll have an options to access the courses. You'll see Tom's face. You'll see all the different great courses we have there. And that's where you can definitely chime in on one of the course opportunities. Awesome. Well, with that said, this is the end of lesson 2. We'll be coming into lesson 3 next week. Expect the update for that inside of Mighty Networks. And hey, everybody, appreciate all the time. If you're watching this in the future, definitely enjoy doing those drawings. And we'll see you next week.
See you next week. Bye bye.
See you, everybody.